What's up everybody? Welcome to the channel, Flash 001 USA. Today's Sunday, April 1st, April Fools. The year is 2024. I hope you guys are looking forward to the changing of the seasons as much as we are. We're really looking forward to putting the garden out this year. Okay, a little over 3 weeks ago I uploaded a video to the channel covering the topic of homemade batteries. Now we're talking about batteries that you could use for emergency use, or some people may find this video as an educational thing or just a curiosity thing. But we're talking about batteries that the moment they're assembled, they're fully self-charged and ready to put into service. When I made the video, I said I would probably do a follow-up on this topic, which is where we're at right now. Since that video, I've learned quite a bit more about this, along with a couple of things that I know are worth sharing with everybody. Now, one of the things we're going to start the video off with is going to be how to make waterproof homemade conductive paint that you can use to put on electrodes and current collectors that protects them from the electrolytes in the batteries. We're talking resistances on this down to less than 1/4 of an ohm. That makes this paint killer because it makes the batteries extremely efficient, and the more efficient they are, the more you're going to get out of them. Now, as mentioned, this is going to be a video that's going to be a rehash of the prior video. So this time around, we're going to build a slightly larger battery. We're going to get down into the devil of the details. We're going to make this video flow smoother so you can see exactly what's going on with it. And we're also going to include a time-lapsed video of this battery under load discharging for those of you that may want to see this. I may or may not, I don't know yet, but I'm considering including on this at the very end of the video a list of tools that you need should you want to try this for yourself. So if you see it there, you know I put it there. If you don't, guess what, I didn't. So on that note, let's go to the bench. All right, spoiler alert, because I've been so busy. I made the majority of this video a little over 3 weeks ago, 2 weeks ago, somewhere around there, right after the first video. I have been so busy, I'm just now getting around to piecing this thing together and doing the intro today for you guys on April Fool's Day. So on that note, seriously this time, no April Fools. We're going to go to the bench and do this thing. Now before I put this battery together, we're going to cover how to make the graphite solution, along with a couple of other things that are relevant to this video and the construction of this battery. To make up the graphite solution, you need the following. 1 small glass jar with a quality lid that seals good and tight on it. I will tell you right now, you can go with something 1/4 of the size of what I've got in this video and still have more than enough jar than you'll ever need. Next thing you're going to do, add 1 tablespoon of acetone into the jar. The next ingredient will be clear nail varnish. Sometimes they call it top coat. You're going to put between 25 to 30 drops of this stuff into the acetone solution, at which point you're going to stir it up until it disappears. You need to have something like a stainless steel stir stick when you're mixing this stuff up. Stir it up until it totally blends in and you can't see it in there anymore. The final ingredient, the magic, will be the graphite powder. You're going to add 1 teaspoon of this into the mix, and the stuff is pretty fluffy, so it's going to look like you're adding a lot, but it's going to be like styrofoam hitting gasoline. It'll melt and turn into nothing. You're going to stir it up until it becomes basically a thin sort of paint. That's what you're looking for. If you realize that you're maybe a little bit too thick, just add a couple drops of acetone with it and be done with it. But what you want is basically a thin sort of paint that will coat your electrodes or whatever you're going to be using it for. If you mix it up too thick, it'll have the tendency to clump up. Now keep in mind, because we're dealing with acetone, it'll want to evaporate fast. So right before you get ready to use this, you mix it up quickly. And then of course the last thing you need will be a decent little soft bristle brush to brush it on like I used in the video. So this is the whole 9 yards with it. As far as graphite, keep in mind you can use other mediums, but you may have to modify the formula a little bit. So you can use other things like activated carbon, or like I did, you can use highly ground down powdered zinc or other stuff like that. You just may have to play with it a little bit to get the consistency that you're looking for. This is going to be our positive cathode and our current collector we're going to be using to construct the battery with in this video. The materials I used was a 2" by 2" square piece of copper foil. I also dog-eared the corners off of it. I don't want anything with a sharp edge that I can snag on and bend this plate, especially before I get a chance to apply the graphite surface to it. Now before we can do that, we got to prep up this copper, and we'll do that with a piece of medium grade sandpaper, something with around 120 grit rating on it. The reason we're going to do that is we need to knock off any oxidation from the surface of the copper. We also want to put a whole bunch of micro scratches in it. And once we've done that, we'll wipe it clean with acetone and allow it to dry. This will allow the graphene surface to really adhere to it, and we'll have a good solid connection when we go to use this battery. Now this step is where the magic happens. But before we apply the graphite solution to the cathode, take a moment, stir your solution up. So we're going to go in here and just mix everything up. Now when I apply this, it's going to be in broad, slow strokes with a light touch with the brush. And we're only going to put a single layer on each stroke. You don't need any more than that. So now we got this. This is the brush. And I'm going to get this out of the way a little bit here. There you go. That's all there is to it. This stuff will evaporate very quickly. Now, if you got a hot plate or something, it would be a good idea to set it on that for maybe 4 or 5 minutes. You don't want extreme heat on it, just enough to harden it up a little bit. You could even put it in the window of an automobile or anything warm, a hair dryer at a distance from it, just to get it cured. And you'll know when it's cured, because if I pick this up right now, the copper under there is going to be ice cold. You know how it is when acetone is evaporating off the surface. So I'm going to let this cure for a few minutes, and I'm going to point out something, let you see something that's pretty neat about this. Alright, we're back, and this had a chance to cure, and I'm going to slowly zoom in on it. At this point, I haven't touched the surface with it with anything since I let it cure. But I'm going to point something out here to you. Maybe you'll be able to pick up on it. Let me see if I can get this where the light can show you what I'm trying to point out. If you notice, it's dull. Now check this out. Take my fingers and just rub on it. And this stuff is on here really well. Now, it doesn't mean you can't take a fingernail or a sharp object and scratch it off. You sure can. But it's on here. You can see what I'm doing with my finger here. And it's not peeling off or breaking away. Now, check it out. It's going to be shiny. I want to tell you where else I noticed this. I've got some factory-made graphite sheets. I think I got one over here somewhere. Let me find it. Yes, I do. And when I first bought this stuff, and I'm going to see how many of you that have worked with this in the past have ever experienced what I'm going to tell you. When I first opened the stuff up out of the package, hell, I thought there was a plastic coating on it. I went to try to peel it off and realized, no, it's not. And then I realized even with this stuff here that's professionally made, you rub your finger on it and it'll go shiny. It'll also put a coating of graphite on your fingers. So I think with this stuff here, the way they do it with extreme pressure. I would love to know what they use for the binder on it. but they do it with extreme pressure and probably run the heat up pretty high on it when they do it to get it to compact. Now this stuff here, you can scratch the surface of it with your finger, and if I reach over here I can break it. Yeah, I can bend it a little bit, but it's not really meant to be bent, and if you bend it far enough you will snap it. Now the graphite that we coated this with, it's on here, and this copper plate is protected, so we don't have to worry about electrolytes or anything else eating into it or any other issues. Okay, what motivated me to try to come up with a better method or a solution for coating these current collector plates is I had been all over the place online trying to look information up on this topic. There's a lot of information out there. The problem is a lot of people are using water-based binders. They're using carpenter glue or white glue or other glues along that family. And to me that creates a twofold problem. Let's cover the first issue. Wood glues or white glues, what happens when they get wet, when water gets on them? They absorb, it gets soft, and it breaks down. Now think about what I'm going to tell you right now. Most electrolytes for batteries are water-based, so you can see how that would be an issue. Now the second hurdle, and to me this is a big issue, is when you use water-based binders, the surface resistance is much higher. Now on what I've got here, I'm less than half of an ohm. I'm way down there. It's almost like wire. What I was experiencing with the water-based binders is it could be anywhere between 5 ohms, 10, 15 ohms. Now people were doing workarounds, and I was one that even tried this. They would try to dope it or add to it some of their electrolyte solutions they were using for their batteries. Or they would supplement it with a little bit of salt or a mild mixture of something acidic or an alkaline solution. And that's okay. It does lower the resistance, but it still won't touch this. It will not touch it with a 10-foot pole. And there's another issue there. Depending on what kind of metals that you're working with. Some metals, they're compatible with the solutions that you're using, and that's why you got to pick the right solutions for the batteries that you're building. Some metals aren't, but regardless, the metals eventually will break down no matter what solution you're using. It's just you're slowing it down by using metals that are compatible with certain solutions. With this right here, these copper plates, they're thin that I'm using. This is real thin stuff, and it just goes on and on and on, and I don't have any problem with it pitting or breaking down. Now when I'm building batteries, like a battery that's with manganese dioxide, carbon, and zinc, yeah, I expect the zinc to break down because that's the cost of doing business. And just like driving your car, besides general maintenance, putting gas in the car is the cost of doing business driving your car. The reason battery manufacturers like to use carbon rods in here is because not only are they cheap, they got a good low resistance, but boy, they'll last forever. They don't really break down inside of a battery. And when you start adding more and more complicated things to a battery with different metals, then the machine gets more difficult and there's more things to break down. So sometimes the KISS factor, keep it simple stupid, really pays off. Now before we move on to the next step of making the resistance measurements on this current collector, there's a couple more things that I want to cover with you that I think would be relevant. The original premise of me making this video was not about building a battery, although we're going to for this video. It was about the method that I'm using to be able to put mediums and coat the tops of these current collectors with them. So I just kind of wanted to point that out. I'm going to drive this forward, get this out of our way, and put this guy in his place. Alright, as I was experimenting with these mixtures, and I was getting it close enough that I felt that I could share it with everybody, I then wanted to try different mediums to see what I could get to work as far as what would stick to the metals. And of course over here we've got the graphite, and then I decided to try to use some activated coconut carbon, which is on this side right here. It works quite well. It adheres to it with no issues whatsoever, but I do want to point out the resistance will be a little bit higher, as where this stuff here is almost like wire. This stuff here is around 4 to 6 ohms depending on how you mix your materials. Just wanted to point that out. Also, we're not limited to stuff just like this. We're going to take it a step further. Let me flip it over. This was a worn out zinc plate that I had made up, and you can see where it just started pitting through. And I got this bright idea because I had a bag of powdered zinc. I wondered if I could use that in the mixture and modify it so that it would be a paint that I could put on the surface. Yes, it worked. It worked like a champ. The resistance is low enough to be usable. It's stuck on there and it's not coming off. So it works not only with graphite and carbons, but it works with metals. I'm assuming, and going to go ahead and stick my neck out on the chopping block and say you could do this with lead powder and other stuff. Not only that, all these materials that we've covered here so far, you're not limited just to painting them on copper. I can tell you right now that I tried this on a rod, like this carbon rod here that I got out of a battery. I wanted to see if I could replace the carbon rod with something else. Well, newsflash, whenever you start substituting materials, especially like in these batteries that are going to be zinc carbon, you substitute that carbon with another material, the voltage won't be right. It may be lower, the current will be off, or something's going to be off with it. So I figured out, hey, look, that a graphite rod works perfect in a battery. It'll replace the carbon rod, and you'll have the exact same characteristics. So I took a piece of metal, I rounded it off at the bottom so that it wasn't like this right here, so that it wouldn't cut when I shoved it down to the battery. And I painted it with graphite and shoved it in there, a metal rod, and it worked perfect. So that kind of was an eye-opener for me. And I figured out real quickly, you can not only paint copper, you can paint aluminum and probably other metals doing this. So it's a redneck sort of way of plating stuff off the fly. I also tried something else here, and this is the last thing we're going to look at. Then we're going to move on to making those resistance measurements. This is a flexible sheet that I made. Now, it's paper towel that I took and I painted it with the material, and I've got the graphite to soak through it. Then I ran it into a laminator. It works. I'm not quite as happy with it that I am with the other stuff because the resistance is around 5 or 6 ohms. I think I can get it better. So the way I see it is, if these people that built this stuff up can get what they get, I think I can get mine a little bit closer. I will share it once I figure it out. All right, let's make some resistance measurements. Now for this, we're going to be using a Fluke 187 meter. What I like about this meter, it's got a calibration feature in it. So it allows me to calibrate out the resistance of the probe tips, the wires, or anything else that's attached to the meter. This way we get a true zero reading up here. Right now it's not calibrated, so let me show you what we're going to read. And we're probably going to see somewhere around anywhere between 80 to 120 milliohms, or for those of you that don't know that, 0.08 up to 0.12 ohms. So we'll clip it together. Alright, you can see what we got down here. Now to calibrate this, I put my probe tips together, and I've got a button up here. It's called REL, which I think means relative. Next to it is a triangle called delta. That's what that stands for. So it's the same thing as when you're using a set of scales and you hit calibrate, you want a zero amount. That's exactly what this does. So let's put the meter together. And now we're zeroed out. Or it should be close enough. It may be like read a 1 or something like that, but it's going to be close enough to 0. There we go. Yeah. All right, let's see what we have here. Now I'm to the side of the camera so I can't see this. I can see the meter, but I can't see what you guys are seeing. I've got a 1/2 inch square piece of copper that I'm putting dead center on this current collector. And I'm doing this because I don't want to gouge this out with the tip of this guy here. He's sharp. And we're going to be using this on the battery build. So here we go. Put him here. I think you'll be amazed at the resistance that you're going to see on this. I'm trying to do this over the camera, so I'm stumbling with it. Here we go. That's like wire, guys. That's like wire. Right now we're looking at what, 90 milliohms? Yeah, you can't beat that. I don't care where I move this around on here, it's going to be the same thing. Keep in mind, the whole surface here adds up with itself. So if you go with a smaller surface on it, then you'll have a little bit higher resistance. But if you cover the whole surface with your medium, whatever you're putting on top of it, you're going to get pretty much the equivalent of measuring wire. I want to do it one more time just to be really clear on this. Now, I'm not really bearing down hard on this. I've got it held in place firmly, but I'm not like mashing the dog poop out of it. Just want to let you know that. Yeah, you can't beat that. Oh, and if you're ever curious about what the resistance would be on a carbon rod out of a battery, may as well throw this up here. There you go. So you got about 240, 250 milliohms of resistance on a carbon rod. Yeah, I was highly impressed when I got to reading the resistance values on this stuff after I painted the surface. Now, I mentioned, let me see if this is in the camera. I mentioned this activated carbon. I may as well let you see it. I'm here, you're here, we're having a party, baby. So, do this, and you'll see what I was talking about. Okay, 2 or 3 ohms. I was off. I couldn't remember what it was. Still pretty low. For all practical purposes, nice and low. That's activated carbon. Now we're going to take a moment and cover what's inside of a commercially made zinc carbon battery and what we will be using in the battery on the bench that pretty much matches up with this. I've got a battery here that's already gutted out. The zinc shell is our negative anode. Now inside of this battery, if you look right here, you're going to see something that looks like brown paper. That's exactly what it is. It's just like old brown grocery sack paper, but about twice as thick. Without that, the battery will not function. And we're going to have to cover that in a little bit of detail, but it's not going to be too difficult. The black stuff in here is manganese dioxide along with carbon black. This is the cathode mix. It is not the cathode. The cathode would be considered the carbon rod that goes in the center, or in our case, for what we're building on the bench, what we coated with the graphite today. This is going to be our cathode. So the next thing we're going to do is we're going to discuss this cardboard in here, because this is something that you need to know about. This is the paper we're going to be using for our cathode anode mix. Let me show you what I got. I actually got this out of the bottom of a box. It's what they lined the bottom of it with, I guess, to give it a little more tensile strength. But it's brown paper, just like a paper sack, but just slightly thicker. So it was most excellent for what I'm going to be using it for here. Now, as I studied more online and learned about batteries and whatnot, I keep on finding little nuggets of information, and I found something out about this brown paper. It is not just plain brown paper that they use. Well, it is, but they dope it or they embed it with something that will make it conduct. The reason they do that, they want to make sure that the manganese dioxide can react good with the zinc so that they have good current flow on it. Now, this is very simple to make up. You can either use a teaspoon of salt if you're making your battery with a salt base, or if you're doing like me and you're using actual ammonium chloride, you take a teaspoon of ammonium chloride, either one of them, you put it into a plastic baggie like this right here, add about half a cup of water to it, shake it up and get it broken down where it's mixed up good. Use a warm tap water. It's not critical. Take all of your cardboard, like I got here, shove it into the bag, shake it and bake it, and you know what I mean, just mix it up good till you see that the paper is saturated. Pull the paper back out, hang it up and let it dry. Now you've got your conductor paper. I actually can feel the grittiness on this where I soaked it up. I'm not sure if I used salt or ammonium chloride on this because I got 2 different batches I made up. Very simple, very straightforward to make. The main thing about this information is it'll probably transpose across a lot of different battery builds that you try. Just wanted to make you aware of that. Okay, something else that we need to cover here that I did not cover in the last battery video that I made. I wasn't even aware that they were using this stuff in the production of batteries. I didn't find this out until I started diving deeper and reading more into some technical papers online. They call this stuff CMC powder. It's basically an ultra fine powdery cellulose, an edible cellulose. And you can see the pictures of the ice creams here. And this stuff is used in ice cream because it gives it its creamy texture when you're eating it. But for batteries, it serves a completely different purpose. It keeps the batteries from drying out. So they use this as an electrolyte paste, and they use this on the cardboard. That's going to be spaced between the anode and the cathode, and it gives the battery better current and also allows the battery to last longer because it just doesn't dry out. Now the battery will work without it, but it will dry out faster. And this stuff here is worth its weight in gold. I'm going to show you how to make this stuff up. It's stupid simple. Get you a plastic baggie for a sandwich, put 1 teaspoon of that mixture into the baggie. It's very fine powder. Add about 1/4 cup of warm tap water to it, and you'll mush it up in your hands. And it'll be a slow process because you'll realize that you'll have splotches in it, but you give it a few minutes, it'll go clear like it is here. You may see some air bubbles in it. Now, if it's too thick, add a little bit more water to it, but you don't want this stuff where it's runny. I'm going to show you something here. This stuff is not pouring, but of course if I sat here for 10 minutes it would eventually ooze down the bag. But this is electrolyte paste. Now when we use this stuff, I'll scoop some out, and depending if I'm making a battery that's salt based, alkaline based, which would be potassium hydroxide, or if I was using something like ammonium chloride, I would actually scoop some of this out into a plastic cup and put a tiny amount in there just to dope it up a little bit so it has a better conductive property to it. So I just wanted to make you aware of that. So you mix this stuff up, and you're going to see me use this in the video when I make the battery. Very simple, very straightforward. So our next step will be to make a battery, and you'll see how all this goes together. It's not that complicated. It's really simple, and the main thing is it works. Okay, in the last battery video that we made and uploaded, I gave everybody a brief description of everything along with a detailed ingredients list and the weight of each individual ingredient that goes into making our cathode paste with. That's what we have in this cup right here. Now all of the ingredients have been mixed, but it has not been activated. The way we do that is to add the final ingredient, which will be distilled water. Then we stir it up and it's ready to go. Now to make this video flow better, I think what I'm going to do is put up a white screen. I'm going to put all the text across it of all the ingredients needed to make up the cathode paste with. This way you see it, you know the weights of everything, and you can jot it down and take notes with it if you'd like to. I'll probably narrate what each individual ingredient is, give you my best description of what I think these ingredients do, how they play in to make the cathode paste work, and I'm going to keep it on layman's terms. I'm not going to try to get real technical or nothing with it, but I will give you basic explanations of everything. But before we do that though, let's go ahead and finish and look at everything you see in front of you and give you descriptions on it. I'm going to give you a hint. That's the whole battery. What you're seeing in front of you is the whole kit and caboodle. So with that said, let's cover the rest of what's in this video. On the left hand side right here, this is our positive cathode current collector. This is also what we coated with the graphite paint. So the other side of that's copper on the back of it. I flip it over like this, you can see this is our copper plate that we have painted. Now think of that, for those of you that are not familiar with stuff like this, will be the positive output of a battery. On the far right hand side is our zinc current collector, our negative anode right here. Think of that as the shell that's under the battery. On this battery, if you go under this label here, you'll see a gray material, and that's zinc. That's our negative current collector. Sitting in front of you right here, a couple of rubber bands. This will hold our battery together. Underneath this is our cardboard, our paper that we activated to make it conductive with either salt or ammonium chloride. Now underneath this, I have two 3" by 3" 3/16" pieces of Lexan. This is what we're going to sandwich our battery in. Now I will let you know this. I'm making my battery out of this stuff here just because I got plenty of it around. You could do this in a lot of different ways. It's just up to the person building it, what you want to use to construct the battery with. With that said, let's take a look at these ingredients, and then we're going to put this puppy together. The first ingredient is going to be activated carbon. We're going to be using 5.3 grams of activated carbon. Now its role is to set up the proper ratios with the next ingredient that I'm going to mention. That will be manganese dioxide. and we will be using 3.5 grams of manganese dioxide. You have to set the proper ratios up here for the battery to function correctly. Now, I had to figure this out by the school of hard knocks, mixing it over and over and over until I found the right proportions of this stuff. Think of it like looking through a telescope and adjusting the focus until you get the best, clearest view that you can see through it. That's kind of what it is with these two ingredients I mentioned. They work together in conjunction with each other to set up the proper ratio. Now, the manganese dioxide, this is your workhorse right here. This works for the electron flow, or this is how you get the current out of the battery. And this is what gives you the activity, so when the battery's put together, that it's immediately putting out power, putting out current. If you were to leave the manganese dioxide out and use every ingredient like I've mentioned so far, you would have basically a supercapacitor. It'd be a kind of like a battery that you could charge it up and it would deliver some power, then it would die out. Or if you charge it up, you would set it down and maybe in about 4 or 5 hours it would slowly discharge like a capacitor would. So the manganese dioxide is very important to this. Our next ingredient can either be common table salt or ammonium chloride, which is what they use in a lot of earlier batteries and still use to this day, I think, in some of the basic heavy-duty batteries. If you use table salt, use 2 grams of table salt. If you use ammonium chloride, use 1.1 grams of ammonium chloride. If you were to put those in 2 piles next to each other, I think, if I'm not mistaken, they would actually, volume-wise, would look almost identical. Now, these actually give the battery its current, gives it its oomph. Without these ingredients here, the battery will not have good current flow through it. So just wanted to bring that up and point that out. The next ingredient, and hell, I don't even know if they use this in batteries or not. But like I said, I played around with this and experimented with it over and over until I got the best battery that I could produce here. The next ingredient is citric acid. You're going to use 1.3 grams of citric acid. What I found out with this is it gives us a higher voltage in the battery. So without it, I wound up with a battery that had around 1.3 to 1.4 volts. But when I added the citric acid, it was anywhere between 1.5 to 1.6 volts. So I wanted to bring that to your attention. Now, our last ingredient will be distilled water, which is also the activator for our cathode mixture. I'm only going to give you an approximate weight value for this. It's going to be approximately or roughly around 3.5 grams of water for the proportions of the rest of the ingredients that I've already given you so far. The reason being, this is going to be one of those things that you got to feel it out or play it by ear a little bit as you mix it up. The good thing is, in a moment when we put this battery together, you'll see me do this in real time, and I'll give you a little bit more detail on this. What we don't want to wind up with is a cathode mixture that's either too wet or too dry, because either way the battery will not function as good. So think of this like the porridge and the 3 bears. One bowl was too hot, one was too cold, and one was just right. We want it to be spot on as far as our water mixture. This is easy enough to figure out. What we don't want to see is water physically running out of it. If we squeeze it, you don't want to have water that runs out of it, but you do want to see the moisture come to the surface. You don't want it so dry that if you squeeze it that you don't see any kind of moisture come to the surface. If it's too dry, then the battery will have a low current flow and the life on it will be extremely short. So with that said, let's go ahead and put this thing together. And I think once the battery's put together, I'm going to make a time-lapse video. We're going to let this battery discharge into a load, and I'll make a time-lapse video so you can see how well the battery functions. And I think you'll be pretty surprised of just how well this thing works. So on that note, take a standby, and we're going to jump back on the bench and make this magic happen. Okay, the moment we've been waiting for. Now the battery's going to go together really fast. What you see sitting in front of you is the non-activated cathode paste. For now, we're going to move them off to the side. We're going to take our carbon paper here, our spacer paper, set them down here. We're going to get them wet just a little bit. Now, I'm using distilled water for this, just so you know. So we're just going to get them good and damp and have them on standby, ready to be used here. Notice I didn't just slosh it down and soak it. I've got enough where it'll just go through the paper and have it good and damp here. Now that we got this ready, we'll peel him back up, set him aside. Now we're going to activate our cathode paste. This is pretty much simple and straightforward. I've done this enough times where I can almost do it without measuring. But for you guys, I want to show you what we're doing here. So I got my little spoon that I've trimmed down. Now I will not add the full amount of water to it. I'll just add enough water to it to get it really good started, because I would rather have too little than too much, because it's easier to correct it if it's a little dry. So now I'm off to the side of the camera. I can't see this. I think I'm in the center of the camera. Now I'm stirring it, which is going to activate our cathode paste. As mentioned, you don't want this stuff muddy. And for this part of it, once again, it's better to be a little bit dry than too wet, because we can correct this when we dump it out on the plate. And the plate is to keep things neat and keep things from getting messy, because we are dealing with carbon here. This is why I've got the gloves on. Okay. What I'm going to do now is dump this onto the plate. Squeeze it all together. This is how I feel it, to see if it's too dry or too wet or whatever it's going to be. Right now it's sticking together, but it's still too dry, but I knew it would be, and that was on purpose. We'll start off with about 4 drops of water. We'll massage it in. Now I just put 3 drops on it. It's getting really close. I can feel it already. It is so almost there. Not quite yet. 2 drops of water. I think that's going to get it. Oh, it's so close. I'm going to do 1 drop of water. That's funny. 4, 3, 2, 1 drops of water. Ignition, blast off. Okay. I think we're there. Let me see. Yeah, that's got it right there. Get the stuff where I can pick it up without having to fight it. It wants to suction cup down to the plate here. So I want to get a ball rolled up here and set them aside. As a matter of fact, while I'm at it, because they're getting ready to go to the next step, I may as well clean the plate off a little bit, keep things somewhat sort of tidy over here. Okay, I don't know if I pulled this out of the camera. I hope I didn't, but what I did was I massaged it and added drops of water to it until I got it to where I needed it to be. We'll set them aside. So now, guys, we're to the next step. We're bringing the paper back. Now remember that electrolyte paste I was talking about? Now he comes into play. So we smear this in here. This stuff is almost like a thin Vaseline. It even feels that way with the texture, and even kind of looks like it. So there it is. Notice I just did the center of it. Don't need both sides of it, because what we're going to do now, we're going to take our zinc anode. That's this guy right here. We're going to lay him face down into it. Now, something I didn't mention, I guess I need to mention this. You notice on everything I got copper strips. This is because I got a bunch of this copper. So I soldered it to one side with just a tiny amount of solder. But the side we're going to use for the electrode is the side that's opposite of this copper. The same thing on our cathode too, so just to be aware of that. So now we set him here. We fold this over. This is done. And of course, this side here will be the side that's going to be part of our battery. Now we've got our positive cathode, and I'm going to use just a very tiny bit of the electrolyte paste on here. I'm not going to go crazy with it. Just enough to shine it up. No more. Don't need to goop it down or anything. Just enough to smooth things over. Now we take our doo-doo ball. We put him dead center. I'm going to mash him down. And I'll level it as I'm going along also. So this will have a level surface when I stack the rest of the battery onto itself. Okay. This is not rocket science. Let me repeat, not rocket science. So there's our cathode paste on our cathode current collector. So now I want to put, as soon as I wipe this down, this piece of Lexan down. I'm setting him on here. Double checking to make sure I set this thing on here correctly. I don't want to set it on upside down. It would probably still work, but let's do this right the first time. So now we set him on here. You know, before I do that, I think I'm going to do something else here too. Just 1 or 2 drops of water here. Make that 3. Just to make sure that everything has a good solid connection on it. So I'll rub this in. I don't have it where it's dripping, but I got it where it's good and wet. You can see the shininess of it. So now I'm going to drop this on top. Guys, that's the battery. Let's center it a little bit here. Put the top piece on it. Now I'm going to use the rubber bands and sandwich this thing together. I'm out of camera for a second. Just have to trust me what I'm doing here. Alright. That's it. So the rubber bands just kind of hold everything together for us. Now let's take a voltage measurement, and then we're going to take a current measurement. For that matter, I don't even need the plate up here anymore. So we'll set him right here. I need room for the meter so you guys can read what I'm reading. Taking the old gloves off, don't need them because from this point forward we're going to be sort of kind of pretty much clean. I'll make sure you guys can read the meter here. So stand by while I center everything up. First thing we're going to do is a voltage measurement. .55, pretty much where I said it would be, almost 1.56. Let's do a current measurement on this. Now this is going to be a dead short. We're not going to do it but about a second. I'm on the 20 amp setting, and by the way, my meters are calibrated, just so you know. So what you see is pretty realistic. Now we're going to do a dead short, 2.2 amps, dead short. I'm going to go back to the voltage measurement. Since set the camera back up. I'm behind this thing working, so it's like really difficult to do this. Now, I would love to hook the meter up and just let it run and run and run while this thing is under load and it dies down. Both of my meters, and I haven't figured out how to go and change it, but they both time out. So what I'm going to have to do is periodically come in here every 30 minutes, 20 minutes or something, and I will make the voltage measurements on this thing, but I'm going to be running a clock on it. So you'll see the thing running in real time on a clock. Now the load we're going to be using is going to be this guy right here. This is a 1.5 volt flashlight. At full charge, which is what this would technically be, it's going to draw about 75 milliamps. Now the battery will be considered depleted when it's down to 0.99 volts. Now you probably wonder, where did I grab that number out of? Not my hat, I can promise you. Most MP3 devices, including this little flashlight I got in my hand here, most stuff is rated that runs on a single battery to be like 1 volt even, or 0.99 volts. And even then, guys, when I run this battery down to 0.99 volts, I can short it out. And there's still going to be at least a minimum of a current dead short on this thing. If I remember to do it, I'm going to do it at the end of the test. So the way we're going to do this, I'm going to pause the camera. I've got to aim it at the clock so you guys can see the clock with me. And I'm going to set the clock for 12 o'clock. And we're going to hook it up, and I'll try my best to have the flashlight shining onto the clock. And we'll time it like this. And of course, this will all be time-lapsed so I don't put everybody into a coma. Okay, here's the battery, and here's the clock. So what I'm going to do is let this thing count down, and let's see if I can turn this light off here. Yeah, I can. So we're going to let it get to 12 o'clock, and then I'm going to fire the battery off, and that's when the test technically begins. Pretty exciting, huh? If you've seen what I was doing here, you would be amazed I haven't knocked the camera straight over. Almost there. Okay, now that we're into the time-lapse part of this video, if you pay attention, you'll notice through the whole 2-hour time-lapse that the lamp never noticeably dims, and I just wanted to point that out. After a 2-hour run with the battery under load, our ending voltage was 1.034 volts. I immediately put the ammeter across the battery. Our ending current was 1.253 amps. Not too bad for a homemade battery. Now keep in mind that the size of this battery is probably the equivalent of a AAA battery. So I felt that was worth pointing out. Okay, in this video clip we're going to cover some of the basic tools that you need for projects like this, starting with some non-reactive plastic measuring spoons. You're going to also want to have some plastic picnic spoons in there too. Now I'm going to give you a word to the wise. Do not cross-pollinate your chemicals. In other words, don't use one of your spoons, dip it into one chemical or mixture, and then turn back around without cleaning that spoon and dip it into something else. That's a way to contaminate your chemicals and also to throw off what you're building, and you'll be scratching your head wondering why isn't this working like it should. Just a word to the wise there. The next thing that you want to have on hand will be some plastic non-reactive stir sticks along with some stainless steel stir sticks. That's a must-have in your arsenal. Now you see me using this in the video. You'll also want to have a couple of these on hand, soft bristle paintbrushes, because you'll be using this to apply anything that you're mixing up onto whatever you're painting a surface with. So whether it's electrodes or current collectors, you just need the right tools for the right job. The next thing that you're going to want to have, and it doesn't have to be something expensive, you need a basic voltmeter that can measure voltage and current. So you actually can pick up decent meters extremely cheap these days. So just have one of these in your arsenal and you're good to go. You're also going to want a set of measuring scales. These things are cheap nowadays. These are used by jewelers or people counting tiny parts, and of course coke dealers. But these scales here are a must-have, and this one comes with a calibration weight on it. It's got a 20-gram weight, so whatever I'm telling you in the video, you can write that down as the word. Because I use calibrated scales, and by the way, I've got another different set of scales these are compared to. They're right on the money. So when you see mixtures and weights that I'm giving you, rest assured that they were done on a set of calibrated scales. The next thing that was not a bad idea to have would be a mortar and pestle in your mix. You probably recognize this if I do it like this. You see this all the time on drugstore logos. This is great for grinding up stuff like carbon or other things that you feel that are too gritty and you need to get them powdered down a little bit more. So something like this is great to have. And hell, I got this one here, I think for like $7 or $8, and it's stainless steel. I got it off Amazon of all places. Now speaking of grinding down stuff and making powdery dust, it would not be a bad idea, especially if you're sensitive to it, have your dust mask on hand, especially when you're working with graphite powder, because that stuff is extremely powdery down to the micron level. It's not good to breathe it in. The same thing with activated carbon. Some of that stuff is extremely floury. You don't want to be breathing it in. Protect your lungs. The next thing that you're going to want to have on hand, speaking of messes and whatnot, keep you a box of rubber gloves on hand. These things will keep you clean, because when you start dealing with graphite powder and activated carbon, it can get messy. But as you learn the process, you're going to figure out just how easy it is to keep things from not getting messy. Speaking of, behind me, and you don't see it because my shop doesn't have water, I got a bucket back here and I got fresh water in it. So I will go back there and wash my hands off, or wash my hands with the gloves off. And of course, something that goes along with that would be paper towels on hand. I do that because it keeps things cleaner, and the cleaner things are, the easier it is to deal with it. Speaking of, this surface here is a plastic surface. I really don't want to be putting any kind of chemicals on here or carbon, because it smears in, and you can see it right here. Of course, I can get it off, but I got to wipe it off with something like WD-40, which, now that I'm glad I mentioned that, WD-40 is great for cleaning off carbon and stuff like that off your meters, off of anything that you're touching where it gets messy. That, or denatured alcohol, or acetone, or even Formula 409. Now, when I am dealing with the chemicals that can get messy, I got an old plate I keep here. And you've seen this in the last video. I can do everything right here, and this is my messy playground right here. So this thing is priceless. Plus, I can just dip it in the bucket, rinse it, clean, and it's ready to go for the next time around. Let's take a look and see what else we have over here for you. Oh yeah, keep plenty of little small jars around. You know that we were mixing chemicals in them. What you didn't see though is I got some smaller jam jars over here like this. And this is what I keep stuff in, like my electrolytic paste and things like that, okay? I don't just keep them in a baggie and fling them to the side. That's the way to have something get a hole punched in it, and now you're cleaning up a mess. I keep everything like this sealed up, including my activated carbon and anything else that I'm working with these batteries. You also want to have on hand distilled water. That's what I got right here in this bottle. This actually came with a kit that I used for some deep cycle batteries, so I just keep distilled water in it. Now, something else you want to have on hand will be some sandpaper, some fine grit and medium grit sandpaper. You can use this for cleaning electrodes, current collectors, or other things where you need to buff them down. This stuff is perfect. Keep some steel wool around. That's perfect for the job too. I'm looking over here to see what else that I have that I don't want to forget to show you over here. Yeah, that's about it, minus keeping a couple of things around, like some little DC motors or some good LED lights, so that this way you can have something to test the batteries with. Now for me, my favorite is this little light here, because on a full charge battery it draws about 70 milliamps. By the time I get down to 1 volt or 0.95 volts, it'll be down to about 60 milliamps, but it'll still be at its full brightness. And if I'm not mistaken, stuff like this, they rate them all the way down to 0.9 volts before they consider the battery to be dead. I know the little tiny MP3 players that do like that. Speaking of music, I do have another load I have over here. When I'm building up 3 and 4 volt batteries, I hook it up to this radio. Now, of course, I've got it set up with wires out of the back of it, and this allows me to test batteries like this also. Plus, I get to listen to some talk shows or tunes or whatever else I want to listen to. I'm looking over here to make sure that I haven't missed anything. Yeah, other things that you may want to keep on hand, like I said, would be some cleaners, something to be able to clean up behind you as far as messes go. But organization is 9/10 of the law with this. Okay, there's one more thing that I need to mention here before I forget about it. I have some glass vitamin bottles that I cleaned out and removed the labels from. These things are a must-have. Don't use plastic or anything that's going to be reactive. In this bottle, I've got some distilled water because sometimes when I'm mixing these mixtures up, it comes down to drops. And if you try to pour it in with a spoon, you put too much in, you've made a mess, and now you're starting all over again. In this bottle, I've got potassium hydroxide, and in this bottle, I've got liquid zinc sulfate. Now, most of this stuff here, you're not going to be using it for the build in this video. We will not be using zinc sulfate. We will not be using potassium hydroxide. We will be using distilled water. So having these little things in your arsenal is a must-have. This will make your life so much easier. You'll get so much done with this. And always remember, just when you're finished with your job, clean everything up. This way, when you come back to your bench or wherever you do this at, you're not facing a mess before you start on something else.